In this video, we're going to discuss how to convert our solution algorithm into pseudocode. So we already have our solution algorithm for the original problem statement, and this will guide the steps that we include in our pseudocode. I'm using a text editor program called Sublime Text for this, just to help with numbering the lines, keeping everything organized. This is the type of editor that you might use in actually writing program code. And so, using something like this can kind of help you get used to that format. Another one you can use is Notepad++. That's available on Windows. So there's a lot of different options, but it just kind of helps you get used to that format. So to start out, when we're writing pseudocode, we always have to signal the beginning and end of the program. You can do this with different keywords like start and stop, begin and end. In this case, I'm going to use main and end because these are the keywords that are used in the flowcharting program that we'll be using next, Flowgorithm. And so just to keep it consistent with that, I'll use those keywords. Now, it's important to keep in mind in pseudocode that there is no standard convention for specific keywords that you can use, but generally I use a certain set. But just keep in mind there is no absolute rule. So it's just kind of learning a set of keywords that you are familiar with and understand what they mean. Follow the conventions that, I set out for you here, and you should be good to go, being able to keep things organized and understand what your code is referring to. But any programming language that you may transition to is going to have its own set of keywords and rules, but these are very common ones that are used in different languages. So to start us off, our very first step in the solution algorithm is to prompt the user for high temp and low temp. Now these are going to have to be two different steps in our pseudocode to prompt for high temp and prompt for low temp. Since high temp and low temp are variables, a very important thing to remember is that in code, before you can use a variable, so before you can prompt a user to enter a value for a variable, before you can assign a value to a variable, before you can refer to a variable at all, you have to do what's called declaring the variable. Declaring the variable basically tells the program that the variable exists. Before you declare it, the name of the variable has no meaning to that program. When you declare the variable, you tell the program, first of all, what type of data will be stored, and second of all, what name you're assigning to that particular variable. So our keyword here is going to be declare, and since we're starting within the main and end keywords, I'm going to indent. So pay attention to how each command is indented, each statement, and keep your code organized this way. It'll really help you a lot going forward. So our keyword is declare, and then I have to select the type. So if you'll recall, the three main data types are integer, real, and character. So integer is going to be whole numbers. Real can be numbers with a decimal. Character can be letters, symbols, numbers. So in this case, we're just going to go with integer. We don't really need a decimal point for this calculation. So declare integer, start with high temp. So that is the format, declare the data type, and then the variable name. And I'll go ahead and do the same thing for low temp. Okay? Now that you've declared it, you only have to declare a variable one time, then you can use it as much as you want in that program. So now that the program knows that these two variables exist, now I can use them to ask the user for input that will be stored in those variables. So my keyword will be input, and then I simply refer to the variable that I want that input to be stored in. Now, for the sake of simplicity, I'm not including in here messages that would pop up to tell the user what they should enter, but we will explore that a little bit when we do the flowchart, just so you can kind of see how that would look from the user's perspective. But right now we're just focusing on the logic steps that are that we're going to follow in this program. So we ask for the input for high temp, input for low temp, and then we have to do our calculation for the average temp. Since average temp is also a variable, we need to go ahead and declare it as well. Then we can perform the calculation. When you're assigning a value to a variable based on a calculation, you start with the variable name that you want to assign the value to. Then you include an equals sign, and make sure to always put a space between the symbols that you use. And then you basically write the calculation the same as you would using regular math symbols, and any variables that you use, you simply refer to by the variable name. And when the program performs the calculation, it will substitute in whatever value is stored in that variable currently, based on what the user puts in. So in this case, we look at our solution algorithm, and we see that the calculation is to add high temp and low temp, and then divide the sum by 2. So we would put high temp plus low temp divided by 2, right? Well, don't forget, when you are writing calculations in your pseudocode, you still have to follow the order of operations. So go back in time to math class when you learned about order of operations, and if you recall the PEMDAS acronym, so anything in parentheses will be calculated first. Then exponents, which we really aren't going to do, that's a little bit outside of the scope of what we're doing. But then multiplication and division, then addition and subtraction. So in this case, the way I've written it here, what will be calculated first is the division. Division comes before addition. But we don't want it to divide low temp by 2 first. So, because what we want to happen first is the addition of high temp and low temp, we need to put that in parentheses. So just remember that it is very, very, very important to check your math and make sure that you are also following the order of operations and that you include parentheses wherever needed, so that you will come up with the right answer. So now that we've calculated the average temp, now we can move on to that comparing average temp to the temperature ranges and deciding what message needs to be displayed. Now, the way that I'm going to do this here, I will go ahead and display just what the average temp is, and then use an if-then statement to decide, or to let the program decide what output to give for that message. So our keyword for displaying something is simply output. And the first one's pretty simple. We just select the variable that we want to display. So this will output the value stored in the average temp. Now, here's where our if-then statement comes up. So remember, according to our solution algorithm, if average temp is 80 degrees or higher, we want the program to display a message telling the user that the average temperature was hot. If average temp is 59 degrees or lower, the message should say that the average temperature was cold. And if it's between 60 and 79 degrees, it should display a message saying the temperature was moderate. So our format, and this is going to be a nested if statement, but our format is going to be if, and then whatever condition we put, then, and then whatever statement, what action we want it to take, else, and then a statement for that. And then finally, end if. This is the basic format. So here we're going to go ahead and fill in the blanks. So our very first condition is that average temp is 80 degrees or higher. So we start out with the variable that we want to compare, and then we use comparison symbols to compare it with a value. So our value is 80. How do we compare that to see if it's 80 degrees or higher? Well, there are a few different comparison symbols. Equals simply means that it equals 80 and no other value. Greater than means it would be greater than 80, but not include the value of 80. Less than, again, would mean it's less than 80, but doesn't include the value of 80. An exclamation point and equal sign means that it is not equal to. So it could be any other value, but could not equal 80. You can also combine the greater than and equal symbol to mean that it is greater than or equal to 80. So 80 degrees would be included in that range. Less than or equal to, same thing where it's less than 80 degrees, but 80 is also included in the range. But in this case, what we want is greater than or equal to 80. Then, if that is the case, if that statement is true, then we're going to have the program provide output. Now in this case, the message is not a variable, it's simply a character statement. So we're going to put that in parentheses, or excuse me, in quotation marks. We're going to put that in quotation marks, and we can just write the message that we want to be displayed. So that will display if the average temperature is greater than or equal to 80, then it will display the average temperature today was hot. Now, what if this statement is not true? That's where our else comes into play. Else is the alternative action in case that condition is false. Here we're going to have to do another if statement, which is why this is a nested if, because we also have to check and see if the average temperature is 59 degrees or lower. So if average temp is less than or equal to 59, then we want to display that the average temperature today was cold. And then finally, we do have a third option, our else. For this statement, we actually can put another if statement, but to keep it simple, we really don't need to. Why is that? We'll look at our ranges. So we've defined anything 80 degrees or higher. We've defined anything 59 degrees or lower. And the only thing left is what's in between, which is 60 to 79 degrees. So if we've gone through the logic of these if statements, if this statement was false, the average temp is greater than or equal to 80, and the if statement, the average temp is less than or equal to 59, was false, both of those are false, then the only other place it can be is within this range of 60 to 79 degrees. So our else statement here can simply be to put our third output. Which is simply the average temperature today was moderate. Whenever you're doing a nested if statement, also just be sure that you always have your if and end if statements aligned. If, else, and end if should all be on the same indentation for each statement. You should have the same number of if as end if. So just make sure to double check that and be sure that you haven't left off an end if statement somewhere, because that will cause an error for you. Okay, so now we have our if statements that determine what our output message will be, and now we can just kind of compare and see if our pseudocode matches up and satisfies everything in the solution algorithm. So always go back and double check that. So our first step is to prompt the user for high temp and low temp. So here we have declared both of our variables and input both of those variables, which will request that the user enter a value. Next, calculate average temp by adding high temp and low temp and dividing the sum by 2. So we declare our average temp variable and then perform the calculation to assign the average temp value. Our compare average temp to temperature ranges to determine if average temp is hot, cold, or moderate. This step is kind of combined down here. So in our pseudocode, we move on to display average temp, which is simply output average temp in our pseudocode. Then we combine the two steps of comparing and displaying the message in our nested if statement. So our nested if statement will compare average temp and see if it is greater than or equal to 80. If so, it will output that the average temperature was hot. Else, if the average temp is not greater than or equal to 80, it will check and see if the average temp is less than or equal to 59. If so, it will output the average temperature was cold. If average temp is not less than or equal to 59, then the only other option is for it to be in between those first two values, and so the last else will simply output that the average temperature was moderate. And then we close it out with the two end ifs. So that satisfies every step in our solution algorithm. Now, the next step is to desk check our pseudocode. That will be in the next video, where we will walk through the logic of the pseudocode and ensure that there are no logic errors and that it properly handles whatever input is given to the program.